Hello everybody and welcome back. We're looking at question 12 on our Fermat paper now. How many four-digit integers between 5,000 and 6,000 are there for which the thousands digit equals the sum of the other three digits? And if we didn't know what the thousands digit was, it's sort of the first one in this case. Alright, so integers between 5,000 and 6,000, it's kind of hard to tell whether or not they're asking, like, could 5,000 and 6,000 be included? But of course, 5 is not 0 plus 0 plus 0, and neither is 6. So we don't actually have to worry about 5,000 and 6,000. But what about the other numbers? Well, suppose I had such a number. It has to start with 5, because we're less than 6,000, but we're more than 5,000. So it's 5, and then maybe we follow it with an A, B, and a C. And 5 is going to be equal to A plus B plus C. So I might ask myself, well, how many ways are there to make 5 a sum of some digits? And I could have 5 plus 0 plus 0. Oops. Got a plus sign in there. So that's one way. And this gives me 5,500. It gives me 5,050 and 5,005. So this gives me three different numbers. I'm going to write those a little clearer. Don't know why I'm writing so small right now. But that's 5,500, 5,050, and 5,005. Okay. What else could I have? Well, maybe my biggest number could be a 4. And then I guess I'm sort of have to have a 1 and a 0. And this is going to give me 6 that I could have. So 5,410, 5,401, 5,104, 5,140, 5,041, and 5,014. And you don't have to list them all out. I'm just trying to give you examples. If we have all three numbers the same, there'll be only 1, 5, and then the same three digits. If we have two digits the same, you'll get 3 of them. If we have all three digits different, you'll get 6. And those are my examples. Okay, what else could I have? Well, I could have 3, 2, and 0. And since all three of them are different, that's going to give me 6 numbers. I could have 3, 1, and 1. And since I got 2 that are the same, that's going to give me 3 numbers. So 3, 6, 6, 3. We're looking at 18 so far. Can I think of anything else? Well, I could get 2, 2, and 1. That's certainly a way to do it. And that gives me, again, 3. And so that's a total of 21 different numbers that work this way. Now, the way I've been listing them out is I'm assuming that A is the biggest, B is the next biggest, C is the next biggest. So with 5, we're sort of forced to get 0 and 0. With 4, you have to have the remaining ones add up to 1, so it's got to be 1 and 0. With 3, there's 2 ways I can get the remaining 2. If I have a 2, remember that we need to make up 3, but the next, the B can't be bigger than 2, so it's got to be at most 2. And then you're sort of forced to have a 1 there. Okay, because you can't have 2, 1, and then something else, because it would be 2. And we can't lead off with a 1 or a 0, so that's not going to help us out at all. So we do have 21 numbers that work this way. And 21 is, I assume, somewhere on their answers, right in the middle. So that's going to give us C. And there we go. So we'll flip the page to get ready for our next question, question number 13, and I'll see you there.